Okay, so this is our same paper from the last episode of Calculus XYZ, and now we're actually going to do something kind of confusing if you don't get it presented to you the correct way. So here we go. This time we're going to try to do the derivative of the square root of x. Do this? Okay. And the trick is we're actually going to replace this middle x squared with x and the size with the square root of x. So you'll see right here. So this is x, square root of x, square root of x. Then we're going to draw the same layout as before. Okay, now this one can be kind of confusing. So the change, this whole thing right here is a change in x. So we can just point to it and say this is dx. All of it is dx. Now when x changes by dx, this changes by its own little derivative. Okay, so I'll give you real numbers later on so that it'll make more sense. And yeah, this topic kind of confuses me too, but it was a while back when I came up with this. But so now you just do the same trick as before, you multiply the size, so this is square root of x times the derivative of square root of x. Same thing. And you do the same thing. Okay. So, in case you can't see, yeah. So we have, oh gosh, that's awful handwriting. But the top one you see is the top left rectangle is square root of x times the derivative of the square root of x, and then on the right you have the derivative of the square root of x squared. Okay, well you can just look at the rest of it. Come on. Okay, so now we know that all of this is dx, so we're just going to write our equality again. If I didn't screw up, this should work. Because like when I first came up with this, I just kind of like saw the formulas and I just like, oh, this must be this. And after thinking it through, and some of it didn't really make sense, to make sure you write all the pieces. I wasn't writing this piece when I first did this. But okay, so now you have dx equals all this. You can look at it right there. Okay. So now, oh, now we have to think through. Okay, this is more confusing. We want the derivative of dyx. So we want to solve for that. Now, before we do anything, we have to, I guess we'll do the division first, and then you'll know what I'm talking about. Okay, so let's just move everything over here. So we'll have dx minus d square root of x squared. I'm just going to divide it by 2 square root of x. Okay. Now, actually, I did something kind of stupid, but this term right here, think of it as two dx's, two little numbers approaching 0, while both of these only have one number approaching 0 dx. This one only has one number approaching 0. So you know that two numbers approaching 0 multiplied by each other is going to approach that much faster than these two. So you could have just canceled out this at the beginning. And yeah, I could have just canceled that out in the beginning, and then you see that this actually is our derivative. So I'm going to do this step again with less nonsense. So we have dx equals 2 square root of x derivative of square root of x plus, what was it? Okay, d square root of x squared. I'm just going to x that out at the beginning. In case you didn't, oh well. right? Because this little piece right here is approaching infinity much faster than these other two, which are right here. So now we're just gonna solve for the derivative of d square, no, derivative of the square root of x, okay? So bada bing. I'm not gonna finish that just to bug you. And then we have it right there. Uh, yeah, the derivative of the square root of x, just like you wanted it. Goodbye.